rotations. All right, rotations are a transformation. Our third now, transformation, where we are going to, oh, get this, rotate an object around a fixed point. Rotating an object around a fixed point. So this is a little different than a translation and a reflection. So in a translation, what we were doing was we're just moving a shape, sliding it around the coordinate plane in any direction that we care for, but the orientation did not change. With a reflection, what we were doing is we were taking an image and then reflecting it across an axis. So if you notice, the orientation does change because our points switch spots, but they don't change in relation to the distance from whatever we are switching, whatever we're reflecting them across. With a rotation, what we're going to do is we're going to take a piece, and then whatever fixed point that we do, we're going to rotate it around, and as it moves around the coordinate plane, the shape is also rotating. One way we do this is to rotate around a fixed point. Now, we're not going to do that as much, but you can see it a little bit better when I do this like this. So I'm going to put a magnet there at point D. Now, if we were rotating around this fixed point, if we were doing a 90-degree rotation, we would rotate the shape 90 degrees. And then we're here. If I go back to the original, if we were going to rotate it 180 degrees around this point of rotation, or center of rotation, we would go 90 degrees, 180. Now we're here. This would be our image at this point. If I go back to our pre-image, which we started with here, if we're going to do it 270 degrees, so now we're going to go 3 quadrants. 1, 2, 3. That's 3 quadrants of turning around a center of rotation, which is point D. Now for us, most of what we do, our center of rotation is going to be here at the origin. So let's take a look at that. There's 3 different ways that we're going to rotate specifically. We can rotate any number of degrees, but for what we're going to do, we're going to keep it into these specific blocks. Now, I'm going to put a category here of clockwise, because as we move, we're going to go around the origin in a clockwise fashion. So one way we would do this would be to go 90 degrees clockwise. So that's going from, say, this quadrant, and we're going to turn 90 degrees clockwise, which means I'm going to move 1 quadrant and I'm going to rotate 90 degrees. Okay, I've turned the shape 90 degrees and we've moved 1 quadrant forward. That could happen in any of these quadrants. We could do a 90 degrees clockwise rotation from here, which would mean move 1 forward, rotate 90 degrees. Notice the shape is now turned to change its orientation. We'll also do 180 degrees and 270 degrees. Now for me, the big thing that I remind myself about this is that each of these is a quadrant's worth of a turn. So if I go 90 degrees, whatever quadrant I'm in, I'm going to be in the next. If I go 180 degrees, whatever quadrant I'm in, I'm going 2 more. If I go 270 degrees, whatever quadrant I'm in, 90, 180, 270, I'm back here. Now the twist on this is we can also go counterclockwise. We don't do that often, and when we do it, it's usually the same thing. It's usually 90 degrees, and then somebody will put CC here, counterclockwise. And the thing to remember about that is, if I'm here in this spot, and I go 90 degrees counterclockwise, I'm going to rotate and move to here. Now, it is the same as if I did 270 clockwise. 90, 180, and it comes back around to 270. So when you hear that idea of 90 degrees counterclockwise, it's actually the same thing as 270 clockwise. These end up being the same. All right, don't get intimidated by this. Let's actually try some of these. We're going to take one shape and we're going to rotate it 90, 180, and 270, and then we'll get comfortable with it. The practice is really going to make a difference for this to help you remember what to do, and the practice doing it effectively so that you get the right image when you're done. Okay, one shape we're going to rotate it 3 different times. So this first time, we're going to do just a 90 degrees clockwise rotation. Now we can see the shape here. And let's just look at this first before we do anything. Where is it going to end up? Let's not forget what we know the labels of these are. So there's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If we're going to take this shape and rotate it 90 degrees clockwise, which quadrant is it going to end up in? Good. If we go clockwise 90 degrees, it should go to 1 quadrant over. So it'll be in quadrant 3. Now the rule for 90 degrees clockwise is this. We want to take the opposite x and then switch the values. So let's just walk through that. Now for me, it took me a long time to believe this. Like I had to do the math, I had to check it, I had to try to prove it wrong. But eventually I came to realize that it does work. So let's do it and we'll see when you start believing it. Okay, so we want the opposite x. So I've got 3 here, which means I need -3. The y does not change, okay? And then switch means now I've got -1, -3. Okay, so that's the one we're gonna graph. -1, -3 is here, and that is x prime. All right, don't panic, let's do the other 2. 5, -4, I need the opposite x, so that's -5. The y stays the same as -4, and then switch. -4, -5. 1, 2, 3, 4. -5 right there, and that is y prime. Same thing, oop, I'm missing a parenthesis. Same thing here. I've got 1, -5, I want the opposite x, -1, -5, and now switch. -5, -1. So -5, -1 is going to be right on my symbol here. So -5, -1 is right here. And that is z prime. Well, let's put the lines in, and then we get a visual of this to see if it looks the way that we think it should look. So put that on there, and that on there. Put that on there, that on there. And now let's look. Did it rotate 90 degrees? Okay. So I've got my shape here, and it moved 1 quadrant over, and it turned 90 degrees. It went from here to here. And I don't know if you noticed this, but you'll notice that this line segment XZ and XZ, if we were to extend those, let me get my protractor. If we were to extend those, we do it like that, it would show us a 90-degree angle. So it's turned 90 degrees literally, right? So this has gone 90 degrees to become that. That looks great. All right, let's try it again. This time we're going to do a 180. As promised, we're going to turn this shape now 180 degrees. So don't forget, all right, 180 degrees. How many quadrants are we going to move? We're going clockwise. 180s would be 2 quadrants, 2 90-degree turns. And this is also a reflection across something else. Like, yes, it's a rotation of 180 degrees, but it's also a reflection across the origin. So this shape is going to reflect across the origin, or we're going to rotate it 180 degrees. This one's pretty straightforward. This is the one that I think is the easiest one to do. Let me get my marker here. And the rule for rotating 180 degrees clockwise is opposite, opposite. So we're just taking the opposite of both terms. So when I look at x here, my x prime is going to be the opposite of 3, and then the opposite of -1. Now the opposite of -1 is +1. And then no switch. We're not going to switch it at all, okay? So it's just opposite, opposite, and we leave it as such. So then x prime is at -3, 1, 2, 3, and +1, x prime. So y then would be opposite of 5 is -5. Opposite of -4 is +4. -5, 1, 2, 3, 4. There's our new y prime. No switch, just opposite, opposite. And then z, positive 1, negative 5, which means we've got negative 1, opposite of 1. Opposite of negative 5 is positive 5. No switch. Then we go to negative 1, positive 5. Now my quadrant 2 is in the way. Let me get that out of the way. Let me label that as z prime so I remember what I'm doing. Let me get my thingamajigger here. And then draw my lines in. Bloop. 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 And now we've done it. We've taken this shape and we've rotated to this spot. So it's gone once, twice. We've reflected across the origin. What's interesting here is, like, if I show you that reflection, it's kind of cool. We've reflected this across the origin, which means we've reflected that both on the X and the Y. It is 3 away here. It is 3 away here. It is 1 below here. It is 1 below, 1 above there, right? It's exactly a reflection across the origin, but we describe it as a 180-degree rotation. Let's do the big one. It's the 270-degree clockwise rotation, or secretly known as the 90-degree counterclockwise. I can write that there because I do know one thing for sure. I know where my figure is going to end up. 270 clockwise means I'm going to go 90, 180, 270. This shape should end up here. If I was doing 90 degrees clockwise, that shape rotates up to quadrant 1 here. So let's see how we do this. All right, the rule for this one is we need the opposite y and then switch. Not too tough. Let's put this in here. So opposite y, I've got 3. My x stays the same. Negative 1 becomes positive 1. Now I switch them. 1, 3. Here I've got 5, negative 4. So my x stays the same. I take the opposite y, it gives me positive 4. And then I switch the values. And then here I've got 1, negative 5. My x stays the same. The opposite of negative 5 is 5. Which gives me 5, 1. Let's draw it. We've got 1, 3, 1, 3. There is my x prime. 4, 5. 1, 2, 3, 4, 5. There is my y prime. And 5, 1. There is my z prime. Let's put in our lines. Itty bitty protract. On there, and then straight, and then there. On there, and then straight, and then there. On there. Stop looking at my bald spot. Okay, fine. There we go. 270 degrees clockwise or 90 degrees counterclockwise. And it's there. Our shape has rotated once, twice, 3 times. You can see as this travels, if I could do this, let's see if I can quickly do this. Who knows how this works out? You know, you never know when you do stuff on the fly like this. But if I had like a little paper airplane, I'd make a little paper airplane. Here's my paper, oh boy, this is horrible. Can you even believe you're still watching this? It's just amazing that I still have you here. But I'm gonna make my little paper airplane. This is terrible, it's awful. But here it comes, this is my paper airplane. We make it look like this. It's got a little point on it. And fold it over. So here's my paper airplane, right? So as my paper airplane flies around, it rotates around like this, and this, and this, so that it's pointed right back there. So if it came all the way back around, it's gonna fit right in that spot. I hope that looked good. I don't even know. All right. Let's wrap it up, Mr. Romanovich. All right, just to go through this real quick, remind you what the rules are when we're exchanging those things. Our value is to rotate shapes around the origin. So if we're rotating around the origin and we want to go 90 degrees, what we want is the opposite X, then switch. If we want to go 180 degrees clockwise, we want to do the opposite oppo X, and oppo Y, no switch. And if we want to do 270 clockwise, 90 degrees counterclockwise, we want to go opposite Y, then switch. All right, get some practice with it. If you have some questions, of course you can ask. Good luck.